Okay, so here I have our Journal 25, and we're going to start off with some bell work where we're solving using square roots. In other words, we're solving for x here, and we might need to use square roots to help us solve and get that x by itself. So here I have x minus 1, and it's being squared. Now remember, we don't distribute this exponent inside because that's not how exponents work. They don't work like distributing a number that's out here. Instead, you have to get rid of this square by taking a square root, because we've been doing that multiple times in this section. So to get rid of an exponent, you take a square root. So I have to take the square root of the other side. Now, once you cancel that exponent, the x minus 1 comes down without the parentheses because the parentheses are just there for that exponent. Once you cancel, you don't need the parentheses. Now, the square root of 9 is a nice square root. It's just 3, right? But the thing is, we've learned that when you take a square root, turns out there are two answers. There could be positive 3 and there could be a negative, so we use this plus and minus symbol here. And so from there on, we need to get this x by itself by moving this 1 over. But before I do that, since I notice this is a positive 3 and a minus 3, I'm going to separate this into two equations where I have x minus 1 equals positive 3 and x minus 1 equals negative 3 to make this a little bit more easier to solve. So I'm going to add the 1 over on both sides here. So if I add 1 to both sides, that cancels, and so my x is equal to 3 plus 1, which is 4. And then if I add 1 on this side here, that cancels, so x is equal to negative 3 plus 1 is negative 2. And so from here, these are my two x values. Remember, when any equation has a square in it, that means x will have two values. And here they are. All right, let's try another one here. So this problem, I don't have the entire thing to square root this equation. So this one's a little different because I notice it is a trinomial, right? So with this type of problem, it goes back to like, can you factor and find the factors and then set them equal to 0? So because I notice this is a trinomial, I'm going to try to factor. So what I have here is if I want to factor, I go to this number here and think about what two numbers multiply to give me 9. Well, that's 3 times 3. So from there, I can factor this into x, positive 3, and positive 3. Let's see if this works when we multiply. So positive 3 times positive 3 does give me positive 9. When I add these two numbers, I get positive 6. So these are my two factors. And so then I would set them equal to 0 because the right-hand side is 0. So I'm going to take each factor, x plus 3, set it equal to 0, x plus 3, set it equal to 0, and then solve for x. Now, this is pretty simple. All I got to do is subtract that 3 over to the other side, so that cancels, bringing down an x equals negative 3. And then the other side here is the same problem. If I subtract by 3, again, x is still going to be negative 3 here. Now, it still is that I have two x values. They just happen to be identical x values here. And that's it. So I brought up these two different problems is because we've been working a lot on when we have something that's more in vertex form, right? Like how do you deal with solving for x? So you have to take a square root to get rid of the 2 that's in the parentheses, right? And whereas when you have something more in standard form, well, you have to factor, and then you try to set the factors equal to 0, solve for x. So this is more like vertex form, this one's more like standard form, and those are the different methods we can use, or different strategies we can use to solve for x. Now, I brought up this problem today because I also want us to take a closer look at right here. So let me shrink this down for us to peer into. So what I'm saying is that right here, notice how these two factors are the same, right? If I don't want to write two factors like that, I can write it as x plus 3 to the second power, right? This means exactly this because anything that's squared is itself multiplied twice. So what I'm saying is that I can combine these two and just write a square here. That is going to be a very helpful technique that we use in the next problem. All right, so let's talk about today on different types of problems where they're not factorable. Okay, so I'm gonna just write down a problem that you will notice on one of your homeworks. I believe it's like on your packet on page 2. This is like problem 1, and it looks like x squared plus 10x minus 21 equals 0. So this is a problem on page 3 of the packet, and this is problem 1. And so when people see this problem, they're like, oh, it's just like this problem. I got to factor it. So I'm going to find factors of 21. So let's try to do that. So factors of 21 are like 7 and 3. So we need to know that they add to make us 10. So when we do this, they're like, okay, I got it. 7 and 3 will work. And so we start placing our numbers down. Now, because I noticed that this is a minus 21, that means these two numbers, when multiplied, had to give me a negative number, which means that one of these is a negative and the other is a positive. But which one is the one that's negative and which one's the one that's positive? So I'll make this one a negative and this one's a positive. But here's the issue. When I add these two, that makes it when I add a negative 4, and the middle term is not a negative 4, it's a 10. Wait a minute. If that middle term's a 10, the only way for that to happen is if they were both positives, right? 7 plus 3 gives me positive 10, but when I multiply them, I get positive 21, which is not what's here. So the problem becomes, well, this here might not be factorable. And I'm going to tell you right now, this problem isn't factorable. So when something's not factorable, what do? We can't find the factors, so we can't set them equal to 0, so we can't solve for x. So today's dilemma, and what I'm about to teach you, is how to deal with standard form or a trinomial that's not factorable. And so we're going to learn a few techniques before we get there and solving this problem here. All right, so here we have to first understand that we need, in order to force something to be factorable, we need to make it into a perfect square. This idea of a perfect square is basically what you saw me do before. You notice that when we have something that is the exact same, so if I have something like x plus a, some number is a is some sort of constant, times x plus a, because these are two identical factors, we can just write this as x plus a squared. Just like how you saw me do that with x plus 3 in the last slide. So this here is what we consider a perfect square because they're just two of the same factors squared, right? So what we're going to do today is basically I have almost a trinomial here. There are two terms, and we have to figure out what constant goes here. What is going to be our c value that makes this into a perfect square? And so what we have to start by doing is taking the b value here. So you guys have seen me write something in standard form. A comes first, it's in front of x squared. B is next to x to the first power. C is the constant, right? So when I'm referring to b, I'm referring to the coefficient next to the x to the first power. So our b here is negative 16, right? So b is negative 16. And so what I have to do in order to help me figure out what is going to be my c value is I have to take b. So I'm going to take the b value, and I'm going to divide it by 2. So that's negative 16 divided by 2, which is negative 8. Now, this here is not what goes here. Let me just, a fair warning, this number does not go here. This number is, if you were to factor it, and making into two factors, drop down your x's, this is actually the number that will go here and here. Now, because it's going to be a perfect square, they're going to be the two same factors. So, because they're the same, I can say that they're going to be x minus 8 squared, because they're duplicates, right? But before I get all of this, I've already finished this part, I need to figure out what c is. So watch how negative 8, when you add it with negative 8, it gives you negative 16, which is great. So when I add the two terms, I get the middle term. So to find this number, well, I just have to multiply. Negative 8 times negative 8 gives you 64, positive 64. So c here is positive 64. So basically what you're doing is to find your C value, the new constant that goes here, you have to take your B, divide it by 2, and then multiply it itself twice, which means that you're basically squaring your halved B value. So if you want a formula for this, to find C is basically you're going to take B, divide it by 2, and then you're going to square it. That is the formula here if you guys want it. I don't really ever remember this formula because I just know that when I half B, I get the number that's for the factors, and when I write out my factors, I know to get this number here, I would multiply them, and that's basically squaring them. So like I said, you can have a formula to remember if that helps you. I just never remember this formula because I just know that factors, to get this number, I multiply. So let's try out another one here. So again, we're trying to force this trinomial to be a perfect square like this. So first we have to start out with B. The B here is 8. So we're going to take 8 and divide it by 2. So I'm taking B, which is 8, and dividing it by 2 to get 4, positive 4. So that means my two factors here are going to be x plus 4, because that's a positive 4, and x plus 4, which makes x plus 4 squared. So to get this number here, I would add the 4s to get the 8. When I multiply the 4s to get this number, I get positive 16. And so that's what goes there. And ta-da! I have made a perfect square. So now, let's try out this last one here. So again, you have to start out with your B value and halving it, or dividing it by 2. So our B value here is negative 10, and if I divide it by 2, that's going to be negative 5. And so that means that my two factors here is going to be x minus 5 and x minus 5. And so that makes x minus 5 squared, which is a perfect square. So to get this number here, I would add the negative 5 to get negative 10. When I multiply negative 5 with negative 5, I get positive 25, and I've made a perfect square for this trinomial. All right, now that we've kind of gotten this little bit of that skill in, we're going to apply it in that homework problem that you saw me do where we were stuck when we couldn't factor it. And we're going to, instead of factoring, we're going to do something called completing the square. All right, so here is an example problem before we get into the homework problem. So what we're going to do here is I'm going to tell you right now that this trinomial here is not factorable. Like, think about it. The only numbers that make 13 are 13 times 1, right? But 13 and 1 do not ever add to give you negative 4. I mean, you could just sit there and try, but you're going to waste your time. So this here is not factorable. It's not factorable. And so when something is not factorable, we have to use something called completing the square. Completing the square just makes, which means basically force it to be a perfect square. So you're going to force a trinomial to be a perfect square. And so to do that, what you have to do is basically take this value here and take the C, the constant, and remove it. So in order to remove this C value, right, here's the constant here, we have to subtract it off. Because the reason why we have to take it off is because it's not working out for you to factor. So we need a new constant to make this factorable. So I have to subtract it off, and so now I have x squared minus 4x equals negative 13 on the right-hand side. So the very first step you have to do, and I'll write the step as I proceed, is to move the constant to the other side, or the right-hand side specifically. But you want to move it over because this C here is not allowing you to factor, so we need a new constant. But because we need a new constant, our next step here is we're going to add in our new constant. So what I like to do is add a blank space here for my C value to put in. But anything I do to one side, I'm going to do it to the other side, because if I add in a new C value, then I have to put it on my other side. So I like to create these blank spaces to remind me that I need to fill them out, because I am notorious for forgetting to do that. So I have to create some blank spaces for me to remember. So I make a blank space to find C, essentially. And then from there, I can figure out what C is. So to figure out what C is, remember what we did before? We took our B value, which is -4, the number in front of X. So B here is, B is going to be divided by 2, so -4 divided by 2 is -2. And so that means that when I factor this here, I'm going to have x minus 2 and x minus 2, because that number, when I have it, those are my two factors. And so if I were to add them, I get -4. If I were to multiply them, I get +4. So I'm adding +4 to this trinomial. But we've learned that anytime you add something new to this, you have to add it to the other side, hence the blank spaces on both sides. So when you add that over, right, then these two will combine to give you -9. And so then we're down to this spot here. So once you get down to here, make sure you had factor this guy into its factors, because this here is now factorable. So step 3, if you haven't done it, but I already did, is to factor the trinomial. So once you factor the trinomial, well, then these two here are basically, duplicates of each other. So we can just write that as a perfect squared, or x minus 2 squared. And then when we have a perfect square, it's like, oh, this is just solving for x, right? Just like our bell work, to solve for x, we have to get rid of this square. So we have to take the square root of both sides to cancel out that 2 from the parentheses. So from here, step 3 is, step 4 would be to take the square root of both sides. All right, so once you take care of that 2 there, you just have x minus 2 on the inside. You don't need the parentheses because the exponents cancel. The square root of 9 is 3, but because there is a negative here, that means that this is an imaginary number, so I need an I. But because you took a square root, you have a positive 3i and a negative 3i. So make sure whenever you see a negative sign, just take the square root like normal, but make sure to put an I next to it. And then because it's a square root, you have a positive and negative value. Now, I need to move over this 2 here first. So I'm going to, basically my last step here is to get x by itself. So to get x by itself here, all I need to do is add the 2 over to the other side. But when I add this 2 here, notice how, that's an imaginary number and that's a real number. They're not going to combine. So I'm just going to bring it down the way it is. Now, I like to write my, I have a tendency to write my real number first and then my imaginary number. It really doesn't matter, but this is just a preference that I do. So I wrote my real number first and then my imaginary number last. So then you have the plus and minus 3i on the right side. It's just a preference. And sometimes I forget that and then I just write them as 2 plus minus 3i. But it doesn't matter the order. Once x is by itself, that's all we care about. And now it is. So let's try out some homework problems here. So if you want to turn to your packet, page 3, problem number 1. All right, so here I have this problem that we were trying to do in the bell work, but it didn't work out because it was not factorable. So again, when something's not factorable, you have to remove the constant. So the first step here is to remove that constant that's not working out for you. And so now I bring down what I have left over, which is x squared plus 10x, but I'm going to create some blank spaces so that way I can fill in what is going to be my c value, right? So c here is basically half of b, and then you square it. So if you take half of b, which is 10, divided by 2, that's 5. So that tells me when you create your factors, I have a plus 5 and I have a plus 5. So when you add them, you get 10. When you multiply them, you get positive 25. So I'm going to add 25 to both sides. And so then this side here, when you add 21 with 25, you get 46. And so these two here, I have as x plus 5 squared because they're just duplicates. And then this side here is a 46. To get rid of this square now, so since I've already forced this to be a perfect square, I can try to get rid of this by taking a square root on both sides. So the root and the 2 cancel, bringing down just the x plus 5. The square root of 46 is not a perfect square. And let's just test it out and see if 46 has any identical pairs. So to make 46, you can do 23 times 2. 2 doesn't break down into anything because it's a prime number, and 23 doesn't break down into anything either. It's also a prime number. So since both of these are not identical, we're just going to throw it back in the root. So this looks like you can't do much. It's still the square root of 46. So I can't simplify that any further. Now keep in mind, you still took a square root of a number, so this is still positive and negative. You don't need an I because this doesn't have a negative inside the root, so this is not an imaginary number. And then from here, I have to remove the 5, so I'm going to subtract 5 from both sides. So that cancels, bringing down the x. And again, like I said, I have a tendency to write the number in front of the root. So I'm going to write the negative 5 first, plus and minus square root of 46. Like I said, it's just a preference. All right, and that's it because x is by itself, so we're done. Okay, let's try out number maybe number 6 here. Okay, so take a look at number 6 on page 3. So this problem's kind of nice because what they've done for you, oh, I think I wrote my number 6 wrong. That should be x squared minus 12x equals 10. I think that should have been a 10, yeah. Okay, so back to this problem here. So notice how this side here only has 2 terms and the other side is a 10, right? So what they've already done is taken the constant and moved it to the right-hand side, which is kind of nice. So they've already moved the constant over. I only have 2 terms here, so I'm going to make a blank space next so I can make my new constant. And so I need to figure out what the c value is. So I start by taking half of b. So b here, if I take half of it, that's negative 12 divided by 2 is negative 6. So that number, that 6, is when I factor them, I get a negative 6 on this side and a negative 6 on this side. So when you half it, those are just the numbers in your factors. When you add them, you get you get negative 12. When you multiply them, you get positive. Okay, I can't do math today. Negative 6 times negative 6 gives you positive 36. So I'm adding 36 to both sides. Now, this now is factorable into these two. 10 plus 36 gives you 46. Oh, that's the same number that I got before, right? And didn't we get a 46 before? Huh, funny. So then these two are perfect factors, or so in that case, perfect squares you can write as a negative 6 squared. And then this side's still 46. All right, so if we're solving for x here, I got to get rid of the square by taking the square root of it on both sides. Now, we've already taken the square root of 46 before, so we realized the square root of 46 doesn't break down. So we kept it as the square root of 46, but we needed a plus and minus in front of it. All right, this side here, the 2 and the root cancel, bringing down just the x minus 6. And so from then on, I have to get the x by itself, so I need to move over the 6 by adding 6 to both sides. And so x drops down. This 6 here, I'm going to put in the front because I like to put my real numbers in front of my roots. And there we have it. We have our 6 and then the root next to it. By the way, if you're wondering why I like to write the real number in front of it, it's just because, just give me a moment. If I weren't to write it that way, and I wrote it as plus and minus the square root of 46 and then a plus 6, do you notice that there's a lot of signs here, right? There's that plus and minus, and then there's a plus 6. So if I write it this way, I notice that when it's a positive number, I don't need to write that plus sign. So it's just like decreasing the amount of signs you are using when you write the number first and then the root in the other side, the right-hand side. All right, so x is by itself, so I'm done here. Let's try a really tough problem. Like, you might have noticed all the problems that we've been doing, the x squared, the coefficient in front is just basically 1, right? And so in the previous problem, it was also 1, and before that, it was also 1 in front of x squared. So let's do a problem where x squared is not a 1. All right, so here I have a problem, number 9 here, and there's a lot of wacky things going on with number 9. So let me first say that I notice immediately that the n to the first power, the variable that's to the first power, is on the right-hand side. And it really should be next to this n squared, especially if we're trying to move, if we're trying to make a perfect square here. So I'm going to add that 8n to both sides first. And so this side's now 0. And I'm going to squeeze in this 8n between here, because these are not like terms. So first off, you can't add them directly with each other. So I'm going to bring that over. Let me make this black because it's bothering me. So this is 4n squared plus 8n plus 31. All right, I got my trinomial now. So before I decide to move that constant over to the right-hand side, let me just say that this 4 here should have been a 1, but it's not, right? So the number in front of n squared is a 4. So we really need to make that a 1, a coefficient of 1, because we're going to try to force it to be a perfect square, and you can't do that if that number isn't a 1. So what we have to do is divide everything by 4 to allow this to happen. So I'm going to divide this by 4, but then if I divide that by 4, I have to divide everything by 4. So this cancels, which is nice, so now it's just n squared. If I divide 8 by 4, that gives me 2n. If I divide 31 by 4, that doesn't divide evenly, so I'm just going to write it as a fraction. And then 0 divided by 4 is 0. Now, you guys are probably throwing a fit right now and be like, oh, why does Ms. Chang have to write it as a fraction? Why can't we just write it as a decimal? And I'm going to tell you right now because, well, you can, but when you take the square root of a decimal, you're just going to get a ginormous decimal-like number. And when you have just multiple decimals behind that, it becomes inaccurate, okay? And then some of you guys are like, well, I can just round, and I'm going to tell you, like, that's not an exact answer. And right now, I want you guys to learn how to get the exact answer. And fractions allow you to do that. And also, this problem brings up on how you can take the square root of a fraction. So we're going to work out this problem using a fraction. Keep in mind, this is a tougher problem, okay? I'm not going to put a problem like this on the test, but next semester, you need to be able to handle fractions because we do a lot of fractions second semester. So let's start practicing now. So first off, this is still my constant, right? So I need to move that constant to the other side. So I'm going to subtract 31 over 4 to both sides. So that cancels, bringing down the n squared and the 2n. And so when I do that, I make my blank spaces. I almost forgot to do that. So 0 minus 31 over 4 is just 31 over 4, and I'm going to put a blank space here. And so now I have to figure out my constant that goes here, right? So to figure that out, well, I have to take my b value, which is 2. So b here divided by 2, so that's 2 divided by 2, which is 1. Okay, so if I factor this here, that becomes n plus 1 and n plus 1. So when I add these two, right, they're 2, but when I multiply 1 and 1, that's a positive 1 here. So I'm going to add a positive 1 to both sides. And so then this side here is like, oh my goodness, I have to add a 1, a whole number to a fraction. But it's actually pretty easy. Let me show you. So if I want to add a whole number to a fraction, all I have to do is put this whole number over 1, right? Anything over 1 is itself. And so if I multiply the top and bottom by whatever is in the denominator. So if I'm adding two fractions and they don't have the same denominator, I need to make them the same. So 4 and 1 can both be 4, so I need to multiply this denominator by a 4 to do it. So anything you multiply to the bottom, you must multiply to the top. And so when you do this, then I can get the same denominator and also for it to be a fraction. So I'm going to bring this guy down the way it is, still negative 31 over 4, and then this part here, 1 times 4 is 4, and then the bottom 1 times 4 is 4. And so now the denominators are the same, so you can add the top. So negative 31 added with 4 is negative 27 over 4. See, that wasn't too hard. So looking at these two here, I have two factors and they happen to be the same, so I can write it as, I almost wrote x, n plus 1 squared. Let me bring some more space here. And so now I just have to get this n by itself, so I need to take the square root of both sides. Here I go. So the 2 and the root cancel, bringing down the n plus 1. Now I'm about to take the square root of negative 27 over 4, and you guys are probably like, how do you square root a fraction? Well, it's actually really easy. All you have to do is square root the top and the bottom separately. So like if I were to do this to the side for a moment, like negative square root of negative 27 over 4. Well, the square root of 4 is just 2, right? I'm going to just drop down my n plus 1. So the bottom here is just a 2. The square root of 27 is, 9 times 3. I can break that down. 27 is not a perfect square, so I'm making a factor tree. If you take apart 9, 9 is made up of 3 and 3, so then I have a pair of 3's and a leftover 3. So that means 3 can come out of the root because it's a perfect pair, and then the leftover 3 gets kicked back in. But keep in mind that was a negative square root, so that means that this here has to have an I. So I'm going to put the I in front of it, and then I'm going to treat this kind of like a coefficient in front of I. And then because I took a square root, it's going to be a positive and a negative value. So because there was a negative, I needed the I. Because you took a square root, needed plus and minus. And then I'm done with that part. Now I have to subtract the 1 over. And so I really have n equals, these two are not like terms, so I'm just going to bring down the 1 because that's my real number, plus and minus 3 square root of 3 over 2i. And voila, I have my answer. And I'm done. That one's definitely tough. 10 is definitely one of the harder problems too, but the rest I think you guys should be able to handle. If you need help with number 10, let me know.